Yeah, so this is a second time of the conversation for the programming study for pure mathematicians mostly, but by mostly mathematician the defining the very broad sense. And we even between me and Karen made the conversation and already shared the distributed recorded like conversation last week, but because Benson is happily joined this study, so we'd like to establish the way of the study each weekend and what exactly we want to achieve for each of us. So what let me first try to remind so what we try to establish. So according to the conversation, and I believe they mentioned might saw this like the recorded conversation before. So what we try to study is basically the programming like the languages for sure. So one like the resource would be this one. I mean, number one here, so that we can naively look at, so without assuming any background on Python, so that we can just naively look at the just the basic concepts of each like the Python objects that might correspond to the each object in another language, but we just care just naively catch up the basic idea and the each objects to just read the Python code really naively. So that's what this documents for, and it does not really need to necessary to just read this like the references. If some of us are already be familiar with it, and or if there are other sources, then we can look at it. And another like the problem set for the interview of the industry direction. So this is one of the like the very recommended like a website for the industry job, like the interviews, so that one can just find the tons of like the problems here, so that we can just decide in the weekly basis that how that many problems we can try to study individually and try to share what we have done. So I actually have some certain suggestions so about the, just solving these problems, but before talking about it, and another one is about like the Code Academy, the website that Garen is now typing the details of the organized like useful and elementary like the objects, and Garen might have something to share maybe in the weekly basis for a moment. But with assuming that we have not very strong programming languages, I mean the background yet. So one like the way of the studying in the regular basis, especially for solving those like the interview questions, which might be quite like useful not only for the interview purposes, but also like the learning the like the programming like the skills. So let me just give you some my very naive idea. So for example, if you simply just click each like the problems, then there are very concrete like the guidance of the each problem. So that for example, I do not mean that I'd like to explain the way of solving this problem. I just want to just share my just a very naive like the think how to study each like the problems and try to um just share in the nice like the way. So for this problem, for example, given an array of the integers and on integer, then return indices of the two numbers such that they add up to target. And there are some examples so that it is intuitively very clear for this like the easy level of the problem, and the level of the difficulty is recorded, for example, over here. So statistically speaking. So it definitely matters of the which type of the programming language we'd like to use. So I think we can just simply use either Python or Python 3. But I think we can simply just use maybe this one. So if we already are familiar with just using the Python language, then there might be no like a big like the obstruction, but it might be not the case. So that, for example, we can simply just use the ChatGPT and then just copy without thinking much. Then it completely solved the problem. So the level of the difficulty actually would be not matter, because at least the ChatGPT will provide us the very useful resources to understand it, each like the line by line and the details. So the real matter in that sense is to just the like the regular like the effort to just try to just be used to these types of the new like the languages compared to just a pure academia like the territory in mathematics. You know what I mean? So that, for example, so in that sense, so we can just try to solve for I just give just a very naive idea. So for example, for each day, even though we might be busy with a lot of like the other like the our own duties, so that we can just ask the answers to ChatGPT, for example, and it might take less than an hour or maybe 20 minutes or 30 minutes to just try to digest to understand each problems and the reasonable solutions. And of course, it depends on the problems for sure, but we might be able to just go over 3 to 5 problems each week. That's my basic thought. So that if we are just busy, then just simply just a copy and paste to the ChatGPT and just look at the just Python answers and try to understand and digest as much as possible. And in that sense, we can just make the just a conversation in our like a study that we understand why one needed to make like the come up with the like the code in certain like a structured way, and then we can see the like the complexity of the code and so on and so on, and the very details of the like the Python objects and etc. And one of my suggestion, it does not need to follow, but what I will do is that so there is a Slack channel for my YouTube channel so that I created for this like a specific study. And I hopefully there would be more like a mathematician later on join on this study so that from incoming week, I will just put like some like my own like the progresses of solving those problems in the daily basis. You know what I mean? So for example, just put my schedule to just study those like the problems. I mean, those one because the problems are very like concrete, and I think those are very solid problems to just try to attack. And after I just understand and digest those problems based on the ChatGPT, then I can just share my progresses in the daily basis, so that if any of you are like wanna like follow the like the numbers of the problems that I am actually trying to attacking, then we can make the conversation in the like a casual way, or we can make the conversation more precisely. That's my really basic thought. So that this might not be very like the thing that we can put the lots of the effort in that manner. So that's one thing that I want to share today. And another part, so and before I move on to the another part of the today's suggestion, so please let me know if any of you have any like a suggestion. And it doesn't mean that any of you need to follow what I try to do. So what I want to do is, as long as we'd like to study those problems, it's up to us for like the way of the studying each like the problems. But if I think at least between me and Garen just decided to just go over those problems in the regular basis. So if any of you have no objection, then at least in our own like the pace, we can just try to study them. But it would be good to share the amount of the problems in the weekly basis in order to make the good like the good conversation and discussions. So how about it? So please let me know if you have any like a suggestion or opinions or so on and so on. Otherwise, let me just move on to the different topics for suggestion.
You're suggesting we work on different problems during the week, then we talk about it at the end of the week together.
So it's up to us. We can decide. So
Okay.
what do you think, guys? So we want to study different problems and try to explain for problems, or we want to share the same problem and try to attack the same problem individually and try to just share the like the way of the just thought. So what do you think?
Yeah, I think work on different problems makes more sense. Yeah,
Yeah.
I've never done the problems here before, so I guess we could just see in the
Yeah,
future.
yeah. Then yeah, sounds very good. Then at least we need to, for example, share the. I think it would be good to share either like the so communication in email or, for example, like a Slack channel, so that which and we need to at least pick up the problems to make the explanation when we gather, right? So that it would be good to like define the amount of the problems in the weekly basis. So which problems we'd like to solve. And depending on the problem, that sometimes it might be good to have some overlap, but basically let's just try to distribute these problems so that we can attack the different problems. So that's Vincent's suggestion, right? Yeah, sounds very good. Garen, do you have any like a suggestion or comments?
Everything is very nice so far.
Yeah, so before talking about the next like the topic, so let me first share my really basic like the idea. So the reason why we are now trying to gather and try to study something is So for two of you, you'd like to at least improve the programming like the skills and take some benefit based on the like to try to just understand some like the new territory of the like the computer science, right? But at the same time, so this is my basic thought. So that we already have our own expertise in pure mathematics that at least we know how to enjoy. Even you two decided to change the career from the just doing the research in pure mathematics, but I think at least each of us has our own taste to appreciate the certain like a territory of the mathematics that we at least feel enjoyable. So that what I want to do through this like the study is that I think we all can identify ourselves as our mathematicians so that we have our own like the taste to appreciate certain like the territory of mathematics so why don't we try to overlap our own like the taste of the certain mathematical territory to the computer science and try to take some benefit. So what I mean is not just try to suggest like the research project. What I mean is that so suppose any of you get the job offer some like some point so that you do not want to put any effort any longer on this study. It might be the case, right? Because you'd like to put the effort in the case to just live on this study. But for example, suppose we already like to put certain effort to like make some progress. I mean, in the like towards the like the some research progresses for writing the some CS paper, for example. But it would be definitely beneficial to just combine our expertise of mathematics to apply those like the understanding of certain like the CS algorithms. And if there is a certain like the progresses or improvement compared to like the current known like the algorithms, then some at least each of us can consider to write the paper in order to take a certain benefit. But I don't want to put any burden for each of us so that it really depends on our current like our situation, our future situations, and our own like the taste, whether or not we might decide to write some like the paper for like the progresses of the certain like a project or not. Or in either cases, I think it would be good to try to define the certain like the projects that has the overlap between the computer science, especially machine learning, and our own like the expertise of the mathematics. So let me tell you again, I think even though I think you each of you already understand what I'm talking about, I have no intention to put any burden for each of you. So that even I try to define the certain like the project for each of us, it does not mean that it should be mandatory to share any progresses or it's not mandatory to do anything. What I want to say is that in order to just make our like the life enjoyable, so that I'd like to just define the overlap from the computer science to the mathematics. And the mathematics, what I mean is that it doesn't need to be the overlap between our own like the expertise of certain territory. And there might be certain like the beneficial like the area. So that's what I want to try to do. And if it seems reasonable to study certain references in this direction, then each of us can present in turn. It does not mean that like a academic situation, it does not need to be like a pretend to be the expert. We just try to study certain like the reference, I mean the papers or certain like the basic like the objects in this overlap, and just we can just explain or present in turn. That's my basic just a thought. But even that's the case, I'd like to define like a certain direction very precisely for each of us, so that each of us can consider to write some like the paper. Yeah, so depending on like just performing certain like the algorithm and programming skills, and then at least we can decide whatever like the direction we feel beneficial. That's my thought. So I prepare some like the references with these purposes for today. So do you understand what I'm talking about basically? So let me share the where were we? Uh, not just this guy, but this is one of the reference, but yeah, here we go. So let me now just close these references. We all know what those are. Yeah, so in my understanding, Garen really loves the elliptic curve. And I do not know the exact expertise and interest of the Wen, but again, I do not mean the pure just the mathematics territory. I just try to overlap some very interesting computer science algorithms, I mean, in the machine learning territory, and try to combine either the geometric analysis and differential geometry. So here are my suggestions. but it does not need to be exact these references or the directions. I just dive just try to search what kind of the references or the directions each of us feel fascinating. And if that's the case, then we can just try to just study and just present in turn. And if some like the experiment, we need to maybe study for the like the programming skills so that we can just find something very concrete. So so those are the references I'd like to share today. And this is the overlap, like the file of the Garen, but let me just try to share turn by turn. So one thing for Garen is this one. Let me share each like the link in the chat screen. So Garen has a lot of the like experience of the classification of the certain elliptical defined on the number field. So those should be regarded as just a pure mathematical researches before, but there are also some approaches, because of course this is a certain like the problems of the elliptical for sure, but still there is a certain approaches using the machine learning. And I don't think, even though I do not know any of them, I don't think the expertise of the elliptical, they cannot be better than Garen, in my personal opinion. So that you can, I think Garen can just take a look at the like the elliptical, like the knowledge here and the way they made the progresses and the way they uses the deep learning, and if there would be the way to make the improvement in your own like the opinion, then you can just look at the way of the creating codes and using the way of the data sets and so on and so on. And in that sense, I just feel it might be enjoyable, but it does not mean that you might be able to take the benefit for the like the industry direction. But this is just for the fun, and also start to use our own identity as a mathematicians. And also that you might be able to find the references from this article, for example, to just look at the also recent like the progresses in this direction. But still we are able to learn the like the deep neural network, for example. And even, for example, I might not be really interested in like working on the elliptical on the number field, for example, but we all are interested in like making the like the understanding of the like the I mean the neural network. I mean this like the CS like the knowledge, so that we can also present in turn. So that's my suggestion for Garen. But I try to just distinguish from our like the basic programming like the study to just this just a direction. But the reason is that we are all mathematicians, so that we can at least understand what we are really talking about. I'm not talking about just a detail line by line. I'm talking about the why we feel fascinating for a certain like the territory, and why we try to make the overlap between the pure mathematics like a territory and the CS like a direction. And at least we can give some like the discussion, and at least we can just share our own appreciation. So that's what I think throughout this study. So in that sense, it makes sense to, so make the gathering and try to just study something, because we have some motivation. I mean, you know what I mean? So that so we need to just at least prepare for the presentation, and in that sense we can take the benefit in the regular basis. That's the suggestion for Karen. So Karen, let me know if you have any suggestion for this one. Is it good?
Everything's great.
Okay, so then let me jump into the also suggestion for Wenchuan. So Wenchuan has a lot of like the work last year for the like the manifold with the regarding the scalar curvature, which is actually a very important topic in my personal opinion. And also Wenchuan has some like the papers regarding the hyperbolic space. Yeah, if my understanding is correct. So there are some very recent papers and very important progresses in the machine learning direction. So let me try to explain what the real issue should be. I mean, independent of the specific topics of the machine learning. So the issue would be the following. So let me share the iPad first. So very, very naively speaking, let me say very naive situation in machine learning, independent of the specific directions of this very big word. So there are tons of the data sets. That depends on each like the problems and the many things for sure. So that let me just really naively just draw. Each dot represent the data set, each data. So what is in general, in my understanding, machine learning people and the community do is to assign each data. So let me just denote each data like such as like the point P, and the collection of this data that contains each point P that embeds to the space. And usually this space is just nothing but just a Euclidean space. So given certain like the data that the machine learning algorithm make this sampling, then they eventually assume that each data should sit inside of the certain dimensional Euclidean space. Then by using the, for example, structure of the dot product, then they are able to calculate the all geometry like the quantities such as the length and the like the gradient and so on and so on. But for the differential geometry perspective, which is very standard for differential geometry for sure, so there's a notion of the Riemannian manifold. And if we use this, for example, the function, and usually machine learning community, they want to call such a function either by the cost function or many different other types of, essentially they want to either maximize or minimize certain function eventually. That's the whole like the point of the like running the algorithm. So that there is certain like the cost function, and there are tons of examples, and all they really care is to just find the global maximum or the global minimum. And theoretically it could be possible, but most of the cases there is some like a variation compared to the theoretical perfect like the understanding and the realistic and the heuristic like the algorithm. But so the most of the common like the way is used to call the gradient descent. Gradient descent. And if we use, for example, m to be just the Rn, the meaning of the gradient is very clear in a sense that we just take as we all know. So just nothing but just this guy. So I don't think I need to explain anything here because we all even know how to explain to this to the undergraduate students for sure. But in the case of the Riemannian manifold, for example, then this is no longer the case. So that the gradient actually depends on the choices of the inner products defined on the each tangent spaces. So the usual like the description would be something like this. Of course, there's a more precise description in the like the tensor, like the expressions in differential geometry. But let me just naively let's write in this manner so that there's a like the term regarding the Riemannian metric G here. So the reason why I put the comment on this like the very elementary situation is that the effect of the weight from this Riemannian metric should be depended by the basic assumption which space the data sets are sitting inside. And mostly machine learning community just they assume that data should sit inside of the Euclidean space. That's it. But this assumption is not reasonable in many, many ways. For example, so it is very clear that, for example, if we just look at just a two-dimensional sphere, then the way of the data set sit inside of the sphere should be absolutely different from the data set sit inside of R2. And also the situation sit inside of the two-dimensional hyperbolic space for sure. So that there are some, and also there should be other possible choices of the embedded spaces that makes the calculation that should be different. Because if we assume the embedded space is different from the Euclidean space, then the corresponding way of the calculating the gradient, Laplacian, and all those like the geometry, like the quantity should be changed depending on the choices of the embedded space. Of course, this is just one of the like the direction, but at least this is one very reasonable like the thing to combine the differential geometry knowledge or geometry analysis like the estimate to just combine with a certain like the machine learning algorithms to make certain improvement. So with this perspective, so one thing which is very important, I think very, very important in the machine learning community in general is the so-called transformer. So I don't assume that each of us studied the transformer before, but if one look at the very important transformer like the algorithms from the machine learning, like the articles, then they simply just assume the way of the calculate is just assuming the embedded space should be the Euclidean space. So they simply just uses the dot product. So the spirit of this work, of course, this is not the territory of the pure mathematics. This is absolutely not. But the language of the hyperbolic, like the transform, indeed means the hyperbolic space that differential geometry are usually talking about. So if I just click this PDF file, I just want to share the very like the familiar like the pictures for like the differential geometers, so that instead of the just using those, for example, like the Euclidean space, so just by changing the embedded space to the hyperbolic space, so people wanna claim that there are the beneficiaries to take the benefit by just assuming the embedded space to instead of the Euclidean space or maybe the sphere to the hyperbolic space here, so that they wanna proceed a certain like the experiment and try to prove under at least their data sets that the hyperbolic space gives some benefit. You know what I mean? Of course, it really depends on the data set and also the heuristics for sure. But at least in that manner, one can just try to consider the change the embedded space, and that gives the corresponding all formulas of the algorithm should be changed from the Euclidean setting to the other like the spaces. And for the differential geometers, the hyperbolic space and this like the n sphere is just one of the possible like the situation to change the setting, but also there should be also other possible choices. So with this sense, so one of the very important like the stochastic process for the machine learning community is the Gaussian process for sure. And there is also the way to use the embedding to certain like the manifold by using the heat corner. Again, I'm not talking about the pure mathematical like the research direction, or those are in the territory of the machine learning, so that they want to use the heat corner, which is the solution of the heat equation. Mathematically, is very clear, and they just use those like the solution of the heat corner. So again, I'm not reading the mathematical paper; those are CS paper, but still they are using very familiar language for differential geometers, and then they define the certain like the certain embedding for sure, and then they want to take the advantage for the like the certain CS algorithms, you know. And I don't assume, of course, there should be some like the experts in mathematics. They are maybe some of the author might receive a PhD degree from mathematics before, but I think the expert is we might be actually much better than the like the previous like the researchers in that direction, because they just read it, just study the differential geometry by themselves, but we at least have some expertise in that direction, so that we can also take a look at the way of they define the embedding via the heat corner, and then try to just understand and try to make some like so we can just point out some weakness of their like the understanding, and it might be possible to also try to improve the just a very recent algorithms based on our understanding. So for example, so in differential geometry understanding, we not only consider the just a one Riemannian metric, right? We also can, for example, consider the sequence of the Riemannian metrics with depending on the purposes. And then if we proceed those algorithms, then depending on the data, like the sampling, we might be able to just change the situation by using the, for example, like Laplacian comparison or least curvature, like the comparison, so on and so on, to just change the embedded state, like such as the change the radius of the just the n sphere, for example, or changes the very like specific parameters of the just hyperbolic space, because we know that the radius of the bore would be also the matter, for example. And there are also tons of ways to just apply the differential geometry like the knowledge. So and at least it might be very interesting to try to combine the differential geometry like the knowledge. I think that could be also even beneficial for like the getting the either from the like the big tech, in my personal opinion, because we have the different expertise in that direction. And let me continue to share the articles. So one is this one. But again, I just randomly pick in a sense that so there would be some, this is just a very nice suggestion that so if any of you, I mean, especially mention if you don't feel interested in this like this direction, that's absolutely fine. But I just have very naive thought that you might be interested in like this direction, so that in that case we can just study together for sure. And also let me share this one.
Sure. I'll have a look firstly. Yeah.
Yeah, and also I studied this paper quite long time ago, just for fun. So let me first share the link. And I just wanna show you the very like the familiar pictures for each of us. And then they just change the corresponding algorithm from the Euclidean space, which was previously known, and they just change the setting. And then what they just wanted to say is that so they could improve the like the programming, like the algorithm, like the performance compared to the just a Euclidean setting. That's all they want to say. But again, those are just not the mathematical proof. Those are just heuristics, rigorously speaking. But still, they wanted to use the certain like a mathematical structure, especially geometric structure. But we know that there are also tons of other like choices of the just a selection of the like the embedded space, and this is just one of the like the articles for using the hyperbolic space, for example. Also, it's been a while for this article, but I just read this paper in front, and it was quite fun, my like the experience. Uh, and on one another paper, I also want to share is this one. I couldn't find it, so let me try to find the link. And if that's not the case, then let me just send this file directly. Yeah, here we go. I found it. Yeah, so this one is also quite interesting with the, especially the example. So this paper is to make the embedded space to the n sphere, basically speaking. So that this paper uses the heat corner. This paper uses the heat corner, and they even uses the very familiar like the very known theorem from the differential geometers. But this is again the machine learning paper, not the pure mathematical paper, so that they just make some just a heuristic estimate for fulfilling their own purposes, so that they just have some explicit description of heat corner to just encode them in their like the code. And then what they do is instead of using just the n sphere, they just consider the n simplex. This is such a heuristic reason for like making the code more like the suitable. But they could just use the heat corner to define certain Riemannian metric concretely. I mean, with using the closed form from the just the known formula of the n sphere, but they just use some like the heuristic estimate. And then by using the distance, so from differential geometry, we know that as long as we know the like the heat corner, then we can extract certain geometric data. And they was able to just extract certain like the distances for their like the setting. And then they just compare. So there are some like the sections for the like some mathematical estimate, but I actually don't care. So what I want to just show you is this part. So this part, and so this is just a very like the previous work in the um LNP direction is the more like just a natural learning like a direction, so that they just make the comparison by using their own like the embedding, and they just want to claim that their method is actually better than the known like the statistical method, for example. So in that sense, so that you can just so try to look at it, and so you can just randomly just pick and like the relate like the topics or articles, and you can just present it, and then we can definitely discuss. Um, yeah, so that's my basic suggestion. So let me just summarize what I am currently thinking. So once we just gather in the weekly basis, then we first just review the very like the Python, just the basics for the very basic languages, and try to solve some interview like the questions just by using the ChatGPT or whatsoever. And after we just go over those like the very basics for the computer like the science major, then we try to just present or make some explanation on those like the articles, so I think it could be fun, and we could take the benefit for the gathering for the mathematicians. And if some of us just feel it's not interesting any longer, depending on our own situation, then we can definitely consider to leave from this study, but it's fine. So what I want to do is just by making this like a recorded conversation in public, so that more mathematicians can freely join. And I just want each of us take the benefit without any burden. You know what I mean? So it might be able to just proceed certain like the project. And if some conversation or the idea seems very sensitive, then I will make the video that just eliminate those like the conversations, so that before just making those projects available from their articles that they want to create, I can just hide everything if it seems like the more like suitable for that like a situation. But mostly we can just make this like conversation in public from my YouTube channel, so that yeah we can have some motivation to just give some like a presentation, so that we can just study in the regular basis. That's currently my thinking. Yeah, so I think I just share what I have in my mind. So please let me know if you have any comments or questions or whatsoever. So if there's no like the suggestion or comments, then maybe I can just make the turn to Karen, so that Karen can also share what you have.
Yeah, so yeah, this is the first couple of days I've been working to learn programming and how to code. So I'm trying to look at some resources that could help us learn in a rather organized and quick manner. Kuni, can I share the screen?
Yeah, now you can share the screen. Yeah, sorry.
Okay. I think I'll share desktop. Oh boy, so much. Uh, I can't. I hope. I hope it works.
It doesn't work. I think now any of yeah.
Yeah. Okay. So can you see now? Because my computer is upset, it seems.
Now we can
Okay. So this is project. Sorry, this is Code Academy, and so I've been going on the full syllabus of Python 3. So they have a good organization of how to teach you Python 3. For now, you can see I've completed these sort of chapters. These chapters with lists and loops and functions are extremely important. Towards the end, it seems more focused on software engineering instead of the basics of computer programming. And really, software engineering skills are very important, but the basics is most of what you need to solve questions that you would be asked in an industrial interview, but not necessarily a software engineering interview. So I've been going along trying to solve and work through these chapters. So, for example, you can tell I finished these lessons. If you open one up, it takes some time. My computer is kind of slow, but it gives you kind of a good. It's taking so long. Yeah. So it gives you kind of a description of how the programming works. So for example, there's a page on Boolean variables. There are two Boolean variables, true and false. And this is how Python interprets Boolean variables, for example. And then they gave you some instructions to kind of test it for yourself. Make a Boolean variable true as my baby bool that I did over here. And then you can print it and you can see the result on the right-hand side of your screen. So Code Academy, I suggest it. So anybody who wants to first learn how to program, who has never programmed before, is a good place to start. So I'll slowly work through the Python 3 syllabus. It is very, very good in my opinion. So there's Python 3, like the first chapter, and there's I think two more. And I think the second chapter is more focused for software engineering. I haven't seen the third chapter yet, but the first chapter is very good to start when you have never done any programming before. Then in the case of you trying to do some, I guess, interviews, it'd be good to get some kind of programming questions solved. programming experience, in the sense that if somebody's going to ask you to do something for your work, you have to show some competency. So in the course of trying to study for trying to learn programming, I've taken my own notes in this overleaf file, which I've sent in the Slack channels. I suggest everybody gets a nice text editor. So because I have Mac, I have a text editor. This is it right here, MacVim. MacVim is, I think, pretty good. I'm pretty sure there are better ones, but what a text editor does is it organizes your code, and there's like ways it changes the color to denote different variables or commands, instead of you just writing code 100% in your terminal. So I would suggest you get a good text editor and start using it and solving it and saving your code as scripts and running it that way. So for example, if you follow something I did over here, I can show you how to run a script. I like to use questions from Project Euler. So there's about 1,000 questions. And the first one was, what is the sum of all the numbers less than 1,000 that are multiples of 3 or 5? So for example, a mathematician can solve this using the inclusion-exclusion principle. It's not that hard. You just find how many multiples of 3 there are below 1,000, how many multiples of 5 there are below 1,000, and how many multiples of 15 there are below 1,000, and then do the inclusion-exclusion principle. I've solved this using this script over here. So this is how I would have done it, and this is how Python interprets your code. So this is the for loop I used, and I use MacVim to kind of organize my code. And I can show you how I can get my terminal to open to do a script right now. So I'm going to change the folder to my desktop. I save this to my coding folder, and I'm going to do Python 3. I don't know what the file name is. Okay. PE1. And this is the answer I wanted it to solve. The answer is somewhere in the 200,000s. It computed it in so-and-so, very, very, very short amount of seconds. So I would say that, to be honest, learning how to do the commands and seeing how Python interprets your thoughts is very good. Of course, there are different languages like C++ and Python and Go that interprets coding in different ways. It's in different ways. So it's good to get practice on how each of these languages interprets codes. But then it's very difficult to just learn the language and then expect to be very good immediately. You should solve some questions on your own. So for example, this is a good place to start. The first question on Project Euler. And the questions get more mathematical. So for example, this question I've solved in the past. I don't have the file that I used to solve it. So of course, one of the questions you can ask somebody is, what is the biggest prime factor that divides an extremely large integer? So the only way I know how to do this is you have to use the fundamental theorem of arithmetic. So how do you use the fundamental theorem of arithmetic? How do you get Python to understand what you're trying to do, and how you're trying to kind of organize your code in a nice, elegant way to get an answer in a short amount of time? It's all very important concepts you should try to think about when you're doing code. So for example, I'm sure a human being can sit down and use a calculator and try and divide this number by 2 or 3 or 5 or whatever else until they get a nice prime number, very big prime number. But you also have to understand how to organize your thoughts using code. So here are some of the notes I wrote throughout my time learning how to code through Python, through Code Academy. And then I'll try to use what I learned to solve some questions on Project Euler and lead code. So for example, this is chapter 1 I wrote. I actually don't think it should be chapter 1. I think it should be chapter 0. So before you do anything. And so chapter 2 in the indexing was what Code Academy called Hello World. So Hello World here, I started taking notes on here as chapter 1. So Hello World's chapter is extremely basic. Basically just teaches you how to print statements or how to make a string, very simple string. So for example, a string can be represented in many ways: single quotes, double quotes, or triple quotes. A string is just simply a body of text that a language can understand, how to assign variables, things like that. And as time goes on, you understand some operations like modular arithmetic. Python uses percentage sign to understand modular arithmetic. So for example, for percentage sign 2 is what 4 modulo 2 is, the remainder of 4 after division by 2. So these notes I've been taking should be available to everybody, and I hope everybody can use them to a good benefit. And I think I should show you control flow, right? So as you learn more towards Code Academy, for example, control flow gets more and more complicated. You get more variability. For example, control flow tells you how to test if 2 numbers are equal and things like that. So slowly working through Code Academy is a very good way to learn coding if you've never done it before. Slowly doing the easy questions, I would say, from Project Euler or the easy questions from LeetCode are very good ways to put your ideas into practice. So for example, this is a nice question. So there are Pythagorean triplets, of course, the numbers that can serve as a triple in a right triangle. These questions are done so that you can have only one answer, because you want the only single Pythagorean triple whose sum is equal to 1,000. To find the product ABC, you should use some coding to understand what's going on. So it'd be nice to start off doing the easy questions from Project Euler. It'd be nice to do the easy questions from LeetCode, but I will give some advice that I've read online. Project Euler does not give you any background. You are on your own to know how to do the math and the computer science on your own. If you have a account from LeetCode, LeetCode gives you some background on coding, tells you a little bit about algorithms, a little bit about graph theory and n-binary searches. And Project Euler is more mathematical than LeetCode, and LeetCode is more closer to what you would encounter in a coding interview. So the coding interview questions seem to be closer to coding rather than how to find even Fibonacci numbers, which it could be easy enough to see in an industrial interview, but something like maybe extremely, extremely difficult, like this question, would not be so, I guess, beneficial for you to prepare for a coding interview. It'll be beneficial for you if you can learn how to do this to improve your coding skills, but not necessarily for an interview. So we should consider some balance, maybe heavier towards LeetCode. Okay, Gunhee, please take back the screen.
Yeah. Thank you very much for our explanation and with sharing what you have done. Yeah. So mention if you have like the special comments or like the suggestions, so you can go ahead with the feedbacks of the like the direction of the study, and you can even suggest something if you feel that should be useful for each of us. And otherwise, we can just stop to record.
Yeah, I don't have much prepared. I just want to say that I've been learning coding from the website of Coursera, and I think a lot of people know that. Um, yeah, yeah, that's what I've been doing. Yeah, I've been learning also some machine learning courses from Andrew, and then yeah, I was learning those things. And I haven't started solving coding problems like Elite Code or Project Euler. Those all seem very interesting. I'll look at them. Maybe I have more to say the next time.
All right then. Then let me stop the record for today's conversation. And from next week, we will try to meet on Saturday, 10 p.m. in the Eastern time. Yeah, thanks for our conversation today.